Hi everybody. We're going to do one more type of hypothesis test in this section, specifically hypothesis tests for population standard deviation. Now to do this type of hypothesis test, we need to use yet another type of probability distribution. This one is known as the chi-square distribution. So let's start out by talking about that. First of all, chi is a Greek letter. It looks like kind of a tall curly X, and so chi-square means we're squaring that. Here's a picture of the chi-square curve, and probably the first thing that would jump out at most of us is that it's not symmetric. In fact, it's very much skewed to the right. What that means is we cannot use symmetry the way we have with z and t distributions. Now, the exact shape of the chi-square distribution depends on degrees of freedom. So we'll be using degrees of freedom like we did with the t distribution. Another big difference between the chi-square distribution and the z or t distribution is that the values of chi-square are greater than or equal to 0. There's no negative values. In fact, the 0 is over here at the very left-hand edge of the curve. So no negative values, nothing to the left of 0. The chi-square distribution table, like the t-table, gives us areas to the right of chi-square values. And in fact, using it will be very similar to using a t-table, except that, I'll say it again, we cannot use symmetry because there is no symmetry. We'll use the sub-alpha notation the same way we have in the past with the z and the t. So chi-square sub-alpha means the chi-square value with area alpha to the right of the chi-square value. So for example, if you have a chi-square value here with a sub-alpha, what that means is that the area to the right of it is alpha. Maybe I should clarify that when we say chi-square, that doesn't mean we're going to be squaring anything. That's just the name of the variable, for reasons that I won't get into. For the chi-square distribution with 7 degrees of freedom, let's find chi-square sub 0.90. Remember that subscript is giving us an area. Specifically, it's giving area to the right of the chi-square value that we're interested in, and that area, which we're calling alpha, is 0.90. So I'm looking at a scenario where area to the right is 0.90. And again, we call the number on the horizontal axis, that's a chi-square value, and we call that chi-square sub 0.90. Let's pull up our t-table and take a look. I want 7 degrees of freedom, and just like in the t-table, we find the degrees of freedom down the left-hand column. So there's my 7 degrees of freedom. So I'm looking for a number in this row. Specifically, the number I'm looking for is one that has area to the right 0.90. And again, just like the t-table, the areas are in the header row at the top of the table. So I locate 0.90, that's right there, and I go down to the row I'm interested in, and I get my chi-square value from there. So I'm getting 2.833. So we conclude that chi-square sub 0.90 is 2.833. That's this value right there.